multiple choice part of your review. We're going to do 1 through 10 tomorrow, Thursday, on the multiple choice part of your benchmark. We're going to do 11 through 20 on Friday. Okay, so if you look at number 1, it says expand the following logarithm. That means you're going from one log to multiple logs. The first thing you should see is this 3 outside the parentheses. It has to distribute to the x, the y, and the z. So this should become log base 8, x to the third, y to the third, and that z gets a power of 9 because you multiply the power of 3 that's already on the z with the 3 outside, and that becomes 9. And now what you see is multiplication. And remember, multiplication means addition. So I have log base 8 of x to the third plus log base 8 of y to the third plus log base 8 of z to the ninth. So over here you got multiplication equals addition. That's what we did first. The other thing we have are exponents. And anytime you have an exponent, those numbers go to the front. So this 3 is going to go in front of the first log. This 3 is going to go in front of the second log. And 9 is going to go in front of the last log. So that answer will be written like this. 3 log base 8 x plus 3 log base 8 y plus 9 log base 8 z. And that's your final answer. All right, I'm going to erase it so you can see number 2. So if you need to go back, just rewind back and see what the answer is. All right, looking at number 2, it says rewrite the following as a logarithm. The first thing you should do here is write the word log. Because to write a logarithm, you have to have the word log. Now, when you look at this example here, if you remember back when we learned these, we talked about something with log, said it had a base. On the same side as our log, we had our answer, and that was all equal to our exponent. And then we moved left, right, left. Now in this case, we have the exponent. So the number that has the exponent attached to it, which in this case is 3, is your base. So your base goes down here at the bottom of your G. And that 3 was on the left. We then want to go to the right side of the equal sign, where the answer is. So we're going to write 59,049 in the answer location. So log base 3 of 59,049 is equal to, we come back to our left side, which is where our exponent is, and it equals 10. Notice how 59049 is on the same line as log and the equals and the 10. The only thing that's dropped down is the 3. So this is your final answer. Log base 3, 59,049 equals 10. All right, I'm going to erase these. We're going to go on to number 3. All right, if you look at number 3, it says condense following logarithm completely. So you're going to go from 2 logs down to 1 log. So what I would do first is write the log and the base. In this case, the base is 5. So there's my 1 logarithm. Now, on the first one, we wrote multiplication means addition, and exponents mean that numbers go in front. On this one, the only other thing we haven't written down is subtraction means division. So we have a minus right here. That means we're going to have log base 5 of a fraction. Fraction means division. On the bottom is everything on this side of the minus sign. So over here we have a y. Now, that log also has a number in front, so that 2 was the exponent on that y. So we should have y squared at the bottom. On the top is everything on this side of the minus sign. We have an x on this side. And in the very front of the log that the x is located on is the number 3. So that 3 is the exponent of the x. So we should have log base 5 of x to the third over y squared. That's our final answer. Again, if you need to stop, rewind, please do so. All right, let's move on to number 4. Number 4, we're going to solve the following radical equation and then check for extraneous solutions. That's for ones that do not work. There was one on your constructor response where some of you did not check. You didn't get credit for that, so you got to do it and check it. All right? The first thing you want to do, though, is get the radical, this piece right here, all by itself. Okay, that's the first piece of this puzzle. Imagine that radical was an x. All right, in front of that x, you see a negative 10, and it's multiplied. So to get rid of that negative 10 in the very front, we have to divide it on both sides of the equal sign. So I'm going to take both sides and divide by negative 10. The negative 10s cancel over here. I'm left with the square root of x minus 10 equals positive 6. Now, from here, we have to get rid of the radical. This is a square root. This radical is a square root. To get rid of it, you would square it. If you do it on one side of the equal sign, you have to do it on both. So the square cancels the square root and leaves us with x minus 10. On the other side, 6 to the second power is 36. So right now we have x minus 10 equals 36. The final step is to add 10 on both sides of the equal sign, and we get x equals positive 46. So before we go circling that 46 is the answer, we want to make sure that it's true. So we're going to check that answer. We're going to take the original equation right up here, and we're going to plug 46 in for x. So I'm going to come over here and I'm going to write check. I've got negative 10 times the square root of x minus 10. So I'm going to put 46 minus 10 equals negative 60. Okay? Now, what you would do is type in this left-hand side in your calculator. And punch negative 10, and then you'd hit second x squared to get the square root. Underneath, you put 46 minus 10. If it equals negative 60, it checks out. And in this case, it does. So the answer, go back and circle it, is x is 46. Because it makes that radical true. All right, let's go to 5. 5's kind of a difficult question, okay, because you're going to have to solve a rational equation, but you have to do something with the solutions. It says find the sum of the solutions. What this is telling me is there's probably two solutions. If you remember back to solving rationals, a lot of times in the end, we had to solve a quadratic, and usually a quadratic has two solutions. So the first thing we have to do is solve. The second thing we have to do is add our solutions. Now you might want to pause it for a second and write that down. All right. So to solve one of these rational equations, the ones with fractions, in this case, we need a least common denominator. And remember, everything has to have the same denominator. If everything has the same denominator, we can get rid of the bottom and just solve the top. What I want to do first, though, is take this 9. It's just a whole number. I want to make it a fraction, 9 over 1, so we can see where the top and the bottom are located. Now, if you look at the denominators, you have x, that's a factor, x plus 1, and you have the number 1. Now, if you multiply by this 1 over here where the 9 is, it's not going to change any of your factors, so it's really not that big of a deal. The two factors that should be in your LCD are x and x plus 1, so it should be written like this. X, parentheses, x plus 1. Those are the two factors that make up our least common denominator. Okay? So now we go back to our fractions, each one individually, and we see what's missing. Okay? This first one, the 2 over the x, the bottom has the x, but it's missing the x plus 1. So I'm going to put it in, multiply it on the bottom, and anything I put on the bottom, I also have to put on the top. Okay, so the first fraction was missing x plus 1. Go to the second fraction. That's 4 over x plus 1. The only thing that one is missing is the x. So I'm going to put the x in front so they look the same. Again, though, you're just multiplying it. All right? If I put it on the bottom, I also have to put it on the top. Equals. Now, this one had 9 over 1. So this fraction on the bottom was missing both the x and the x plus 1. So I had to put them both. And I'm going to put them both on the top, too. Now, that 1 on the bottom, I know it looks different from these, but remember, this could be a 1x. That could be a 1x, so that this is a 1x as well. Now, at this point, you'll notice that all the bottoms are identical. So, if you remember when we solved rational equations, if all the bottoms were the same, we got rid of the bottom, and we solved the top. So, as I solve this, I'm going to go ahead and do my distribution. So for this first one, I've got 2x plus 2. 2 times x is 2x. 2 times 1 is 2. All right, when I go and look at the second one, I just got plus 4x. Okay, there was nothing to distribute there. On this one, though, I'm going to distribute a 9x. 9x times x is 9x squared. 9x times 1 is plus 9x. So right now, if you remember back to the beginning where it said find the sum of the solutions, I should know right now that it's quadratic because I see x squared. So I'm probably going to get multiple solutions. What I want to do now is make it equal 0. Okay? And to do that, I'm going to keep my 9x squared over here on the right side. I'm going to move all of these items, the 2x, the 2, and the 4x, I'm going to move them all over here to the right. Now, I'm not combining right now because I'm just going to save myself a line. So what I would do is I would subtract 2x, and I'm going to write it under this 9x because it would combine with 9x. All right? I'm going to subtract 2. I'm going to write it over here at the end because it doesn't have anything to combine with. And then I'm going to subtract 4x. Now I'm going to write it again under the 9x and the 2x because they're all like terms. So over here, everything canceled. The reason I did this is so I can set my equation equal to 0. So I should have 0 equals. Nothing combines with 9x squared. I go to the next one, 9x minus 2x, that would be 7x, minus 4x, that would be 3x. So I've got 9x squared plus 3x. And then I've got this minus 2 over here that didn't have anything to combine with. So now I have a quadratic trinomial. All right, and A is 9, so that's going to play a key role here in just a moment. All right, so to solve this equation, I'm going to have to factor. All right, the method I would use here is the x method. Got my multiplication on the top, addition on the bottom, or vice versa, it doesn't matter. Okay, then I'm going to take A and multiply it by C. 9 times negative 2 is negative 18. In the middle, I have a positive 3. So I need factors of this negative 18 that'll add up to be positive 3, and those factors are 6 and negative 3. So when I come back over here to write those factors, I would have x plus 6 times x minus 3. But this is one of those situations, where my a value is something other than 1. So I have to take both of these factors and divide them by a. Okay? 6 divided by 9 is 2/3. So I've got x plus 2/3. 3 divided by 9 is 1/3. So I've got x minus 1/3. And if you remember back to when we talked about these, if we had a denominator, we took it off the bottom, moved it to the front. Took it off the bottom, moved it to the front. So my factors are 3x plus 2 and 3x minus 1. Okay? Now, to get my solutions, I would take both these numbers and set them equal to 0 and solve for both these factors. So I got 3x plus 2 equals 0. 3x minus 1 equals 0. Subtract 2. 3x is negative 2. Divide by 3. And one of my answers is negative 2/3. It's one of my solutions, negative 2/3. Now my other one, I would add 1. Get 3x equals 1. Divide by 3. And my x is 1/3. Those are my two solutions. But remember back to the question. It says, what are the sum of the solutions? So to actually answer the problem, I would take those two items, negative 2/3, and add 1/3. That's finding the sum. And my answer would be negative 1/3. All right, let's move on to number 6. All right, number 6 says to divide. In this case, you're dividing a rational. So when we divide a rational, we have to keep the first fraction, change division to multiplication, and then flip the last fraction. So the first fraction is 3 over 28 times x. I'm going to change division to multiplication, and I'm going to flip the other fraction, put x plus 1 on the top and 3 on the bottom. And then I'm looking for items that I can cancel. I got a 3 on the top and 3 on the bottom. I can cancel those. Now remember, this x plus 1, that addition or subtraction, whatever it would be, keeps those items together as one single factor. This x and this x do not cancel each other out. So nothing else will cancel. I'm left with x plus 1 over 28 times x. Key here is you got to know the keep, change, flip. Now, when you move down to number 7, this is a multiple choice. There are 4 different functions here, all right? And it asks you to graph, or it asks you which one of these could be a function for the graph. So what you would do is take your calculator, go to y equals, and punch each one of these in. Whichever one looks like the picture is the correct response. And there's only one that looks like the picture. All right? And that one is answer choice B. So practice punching those in so that tomorrow it will be easy. Go to number 8. Now 8's not multiple choice. It wants you to identify each one as growth or decay. Now remember, you're looking for the number inside the parentheses. Growth happens when that number is greater than 1. Decay happens when that number is less than 1. So if you look at these examples, the 0.5, that's less than 1. That's decay. 3 is greater than 1. That's growth. 0.75 is less than 1. That's decay. And 1.5 is greater than 1. That's growth. Okay. Let's look at number 9. All right. We want to write an exponential equation for this scenario. Now, the one thing that I see in this scenario is the percentage. It says 0.7%. To convert that to a decimal, you want to take 0.7 and divide it by 100. And that's going to give you 0.007. So your rate here is going to be 0.07. 0.007. Now, remember the formula is A, the initial value, multiplied by 1 plus or minus the rate, plus if you're growing, minus if you're decaying, to an exponent of t for time. Okay? So if you look at this example, the population of the town initially, the A value, was 93,473. And has increased, so that's a growth, so we're going to put a plus, and our rate is 0.007 to the power of t, or if you put the power of x, that's okay as well. But that would be the formula that you would use to figure out the growth of this town since 2001. All right, let's look at number 10. Okay. Number 10 wants you to see which one of these could be the function. Now, notice a few things. I see a hole where the x right here and right there, the x value equals 1. I see a vertical asymptote. Remember, vertical's up and down right here where the x value is 2. And I see a horizontal asymptote where the y value is 1. Now, you're not going to get anything off the horizontal asymptote from these because they all have x squared on top and bottom. And so for the horizontal asymptote, it's just a ratio or a fraction of the leading coefficient. So all of them are 1 over 1. All right. But what I want to do is take your calculator out, go to y equals, because you're going to draw this graph. All right. To make a fraction, remember you hit math. You go over to the right where it says FRAC, and you can hit 1 or enter. On the top, I'm just going to start with A. I'm going to type in x squared plus x minus 2. On the bottom, I'm going to type in x squared minus 3x plus 2. And I'm going to hit graph. Okay. Now, as I look at this graph, I see that it has a y-intercept at -1, just like that one. It looks like it's very similar to the one on my piece of paper, but I want to make sure that it has a hole where the x value is 1. So I would hit second graph to look at the table and go to where the x value is +1 and see if there's an error. Yep, there's an error at 1 and an error at 2 because at 2 you have the asymptote. So that's probably a good candidate so far, A. But I want to check the others too. So let's go to B. On the top, it didn't change. On the bottom, it's x squared plus 3x plus 2. So I'll change that on the bottom to a plus, hit graph. And the picture is definitely different, so it's not B. All right, you go to C. You go to C on the top, you have x squared plus 3x plus 2, and on the bottom you have x squared minus x minus 2. You hit graph there. And it's similar to the picture that is on our sheet of paper. So what I want to do here is I want to check my table, and I want to check to see, no, at 1 I don't have a hole. Okay, at 1 there's not a hole, so it's not C. Because at 1 it says the value of y is -3. Well, in this case, I see right here there's a hole in my graph, so it's not C. Go to D. Top is x squared minus 3x plus 2. On the bottom, it's x squared plus x minus 2. I hit my graph, and the picture is definitely different. So the only answer that works is A. All right, let's move to number 11. All right. This one, you got to read the question. It says, when 6x over x minus 5 plus x minus 4 over x minus 1 is written as a single rational expression, what is the numerator? It wants to know what's on top. Okay, when you add these together. Well, to add these together, you need an LCD, a least common denominator. Well, you can't factor anything on the bottom, so their LCD is x minus 5 times x minus 1. It's kind of like the one we did earlier. All right, so if I write the first fraction, I got 6x over x minus 5. And it's missing the x minus 1, so I put it on the bottom, and I put it on the top. The second fraction is x minus 4 over x minus 1. And I wrote it over there to the right because it's missing the x minus 5. And if I put it on the bottom, I have to put it on the top. So now they have a common denominator. I can add these items together. Okay, but before I would do that, I would have to distribute the 6x, and I'd have to distribute the x minus 4 to the x minus 5. But it's going to allow me to make one big fraction with the same denominator of x minus 5 times x minus 1. And since this one is a plus, I don't have to worry too much about messing up the signs. So I go 6x times x, that's 6x squared. I go 6x times -1, that's minus 6x. Over here, I've got plus x times x, so that would be plus x squared. And then I have x times -5, that would be minus 5x. Then on the inside, I got -4 times x, which would be minus 4x. And then lastly, I got -4 times -5, which would be positive 20. So it wants to know what the top is. So if I combine all these things on the top, I can find this answer. I'll start with the x squareds. 6x squared plus x squared, that's 7x squared. Negative 6x minus 5x minus 4x. Negative 6 minus 5 is negative 11. Minus 4 is negative 15x. Then the 20 plus 20 does not have anything to combine with it, so my answer is 7x squared minus 15x plus 20. That's what's on the top when it's written as one single expression. On the bottom, you'd have x minus 5 and x minus 1. Okay. Number 12 wants us to multiply. Now, if you remember on these, when you multiply, even when you divide too, the first thing you should try to do is factor everything. So you want to factor everything. And then any factors that are common on top and bottom, you want to cancel. So if you look at this one, and again, I'm not going to do the whole x method because these two should be real simple. If you look at the first fraction on top, a is 1 in front of x squared. A is 1. So this is not that big of a deal. You're looking for factors of 42 that will add up to be 13. Well, the factors of 42 that come to mind are 6 times 7. And if you add 6 plus 7, you'll get 13. So you got x plus 6 on the top and x plus 7. Go to the bottom. Again, a's 1. So I'm looking for factors of 63 that will make 16. 9 times 7 is 63. And if I add 9 and 7, I get 16. So I got x plus 9 and x plus 7. I can already see something that's going to cancel. Now, I got multiplication. Over here, these two, they're not trinomials, but they are GCFs. The first one has a GCF of 3. If I divide out a 3, I'd be left with x plus 10, because 3x divided by 3 leaves me with x. 30 divided by 3 leaves me with 10. Go to the bottom. 3x plus 18. Again, they share 3 in common, and I'd be left with x plus 6. So now, it's a matter of canceling. I've got some x plus 7s that will cancel. I've got some 3's that will cancel. I've even got an x plus 6 on the top here and the bottom here. They will cancel. The only two things I have left now are an x plus 10 on the top and an x plus 9 on the bottom. You can write them in parentheses. You can take them out of the parentheses. It doesn't matter, because nothing there will cancel. And that's your final answer. X plus 10 over x plus 9. Let's move to 13. 13, we're going to solve. And again, just like earlier, we just want to make the bottoms all alike and then get rid of the bottom. Good thing about this, though, is that this bottom and this bottom are already the same. So really, this is the only one we're having to change. And I bet, I'm almost willing to bet, that one of the factors of x squared minus x minus 20 is x minus 5. Okay? So if you factor this one, I need factors of negative 20 that will make negative 1. And those factors are x minus 5 and x plus 4. Negative 5 times 4 is negative 20. Negative 5 plus 4 is negative 1. These factors would be the same for this one, because it's the same trinomial. So, the only piece that my x minus 5 at the end is missing is the x plus 4. And if I write it on the bottom, I have to write it on the top. So now, all my denominators are the same. I can solve the top. I have x minus 3. I then have an equal sign. I have 3x minus 3 minus 1 times x plus 4. Now right here it's important that you write that minus 1, because you're going to have to distribute it to both of them. Okay, so let's work through this. I can't do anything with the x minus 3 yet. But over here I can distribute my negative 1. So I would have 3x minus 3 minus 1x minus 4. So on this right hand side, let's combine some like terms. 3x minus 1x would be 2x. Negative 3 minus 4 would be negative 7. On the other side, I have x minus 3. So now I want to get my letters and numbers. My letters on one side, my numbers on the other. If I look at this, I know that I can subtract 1x from both sides, and I'm going to save myself a step here in a moment. But if I move my x's over here, I got to move my numbers to the left. So I'm going to add 7, add 7. Negative 3 plus 7 is 4. 2x minus 1x is 1x, or just x. So my answer is 4. All right, let's go to 14. 14 says to identify the vertical and horizontal asymptotes. Okay, let's start with horizontal. Okay, remember, for horizontal asymptote, you got a few things here. You're looking at the exponents of the numerator and denominator. If the numerator, in this case, the numerator is equal to the denominator, their exponents are. Up top, that x has an exponent of 1. At the bottom, the exponent's 1. So if they're equal, they're equal, your horizontal asymptote is a ratio of the leading coefficients. Well, in this case, the leading coefficients are 3 and 1. So you would do 3 over 1, which is 3. So the horizontal asymptote would be at y equals 3. Now, the vertical asymptote, to find the vertical asymptote, you take the bottom of the fraction and you set it equal to 0. Well, on the bottom, you have x plus 2, set it equal to 0, subtract 2 from both sides, and your vertical asymptote is at x equals negative 2. Now let's look at 15 because we've got to make a little correction here. In this radical right here, that's not an equals 1. It should be a negative 1. Okay, so make sure you make that change right there. It's negative 1 minus 9b. Now this is kind of like the one you had on your constructive response. Solve it and check it. Both sides have a radical, so to get rid of the radical, you would square each side. You would have 1 minus 7v equals negative 1 minus 9v. And then it's just a matter of solving a multi-step equation. Put your letters on one side, your numbers on the other. In this case, I'm going to take my letters and go left. I'm going to add 9v to both sides. Negative 7v plus 9v, that makes 2v. Now, I'm going to take my numbers and go the other way. I'm going to subtract 1. Subtract 1. Negative 1 minus 1 is negative 2. So 2v equals negative 2. From here, I need to divide both sides. I'm going to divide by 2, divide by 2. My v is negative 1. So I'm going to check to see if that works. I'm going to check it back in the original equation. So I got the square root of 1 minus 7 times negative 1 equals the square root of negative 1 minus 9 times negative 1. Now, obviously you can't punch the whole thing in your calculator. You punch the left in first, okay? So you would go second x squared, 1 minus 7 parentheses negative 1, and you get 2.828, blah, 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 equals, punch the second one in, second x squared, negative 1 minus 9 parentheses negative 1, and you get the same thing, 2.828, blah, 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 blah. So they check. All right, so the answer you know is negative 1. All right, move to 16. 16 is just like 14. Vertical and horizontal asymptotes. Start with the horizontal. Okay, so for horizontal asymptote here, you see that the numerator and denominator have the same exponent. That exponent is 2. So you take and make a ratio of their coefficients. The coefficient on top is 2, the bottom it's 3. It will not simplify. So your horizontal asymptote is 2/3. Now, for the vertical asymptote, you have to factor everything first. So on the top, if you factor the top using the x method, let's say you need factors of 6 that will give you negative 7. So that would be x minus 6 times x minus 1. But you got this number in front. So you got to divide both of these by 2. 6 divided by 2 is 3, so you have x minus 3. 1/2 won't simplify, so you would have 2x minus 1. So you're going to move that 2 in front. So that's what the top would look like once it's factored. On the bottom, you got 3 times negative 12. That's negative 36. Factors of negative 36 that will give you negative 5 are negative 9 and positive 4. You got this 3 in the front, so you got to divide. Negative 9 over 3, that's going to give you x minus 3. That 3 goes to the front. You got 3x plus 4. The reason we did that is because this rational has a hole. These x minus 3's that cancel means there's a hole at positive 3. So you want to take what's left on the bottom to find the vertical asymptote. And what's left on the bottom is 3x plus 4. Set it equal to 0. Subtract 4 from both sides. And you get 3x equals negative 4. Divide 3 on both sides. X is negative 4/3. All right. 17, for which set of values is the algebraic expression undefined? Look at the bottom. What numbers could you put in for this x or this x that would make their parentheses equal 0? The first x, if it said negative 2 plus 2 is 0. The second one, if it said 6 minus 6 is 0. Those numbers would make it undefined because you cannot have 0 on the bottom. So the correct response here would be D. All right, number 18, the last one. This is a cross multiply situation. X plus 3 times x minus 2 would be x squared minus 2x plus 3x minus 6 equals 3 times 8 is 24. So you have a quadratic. You want to set it equal to 0. Right now it equals 24. Subtract 24 on both sides. Write it under the negative 6. They will combine. So you'll have x squared plus x minus 30 equals 0. And so to solve this equation, you have to factor the x squared plus x minus 30. So I need factors of negative 30 that will make 1. Those factors are positive 6, negative 5, and then I'm going to take each one, set it equal to 0, and solve. X plus 6 equals 0, minus 6, minus 6. One of my answers is negative 6. Take my x minus 5, set it equal to 0, add 5, x is 5. So the correct response here is E, negative 6 and 5. Got any questions? Make sure you ask before you leave.